So in this video, we're going to take a look at the first section in Chapter 5, and that is the polygon sum formula. So I want you to sketch a pentagon, and remember, a sketch doesn't have to be perfect. Pentagon has 5 sides. And the question is, how many triangles can you make by drawing diagonals from one vertex to all of the others? So you can pick any vertex. So let's pick this vertex. So remember, a diagonal is a segment that connects a vertex to a non-consecutive vertex. So for example, this vertex and this vertex are consecutive and they make sides. But if I connect this vertex to this one here and this one here, those are diagonals. Now I can make a bunch of other diagonals. Let's say, for example, I can connect this vertex to that one, but that's not what this is asking me to do. From one vertex to all others. And this is the total number of diagonals that I can make. But if I look at this picture, I've made 3 triangles. One triangle here, a second triangle here, and a third triangle here. Recall from what we've learned in Chapter 4 is that the angles in a triangle always sum to 180. So if we want to know how many degrees are in our pentagon, so let's look at our pentagon. We have this angle, this angle, this angle, this angle, and this angle. Well, what we can actually do is break it down and look at the triangles. So for example, in this triangle, we have this angle here from here to here, and this angle here. And those equal 180. But then if we look at this triangle, we have this angle here, this angle here, and this angle here, and those equal 180. And looking at our last triangle, we have this angle here, this angle here, and this angle here, and those equal 180. You might think, well, how's that going to help us find the angles in a pentagon? Well, again, if we look at this angle in our pentagon from here to here, we notice it's the sum of the purple triangle plus the yellow triangle. So that's why when we add up all the angles in the 3 triangles we see, it actually gives us the measure of all the angles in the pentagon. So let's fill in a chart here. So in a triangle that has 3 sides, the sum of the measures is 180, and the number of triangles formed is 1, because you have a triangle. In a quadrilateral, we can connect 2 of the diagonals. Remember, it's just one diagonal or one vertex to all other vertices. So you don't want to do something like this, where you're drawing all types of triangles, because adding up these angles are not adding up the angles in the polygon itself. So a quadrilateral, we can make 2 triangles. And how many, in a quadrilateral, we can make 2 triangles. And since each triangle has 180 degrees, if we do 180 times 2, there are 360 degrees in a quadrilateral. Pentagon, we can make 3 triangles. If we do 3 times 180, we get 540. So let's do one more. Hexagon has 6 sides. This is not the most beautiful hexagon, but you get my idea. Connect one vertex to all other vertices. We make 1, 2, 3, 4 triangles. And again, if we do 4 times 180, we get 720. Heptagon, 5. Octagon, 6. I hope you're seeing a pattern. And each time you take the number of triangles times 180, and that gives you how many degrees are in that shape. So that means for the nth term, again, looking for a pattern here, the number of triangles, we can form 3 sides, 1 triangle, 4, 2, 5, 3. If we kind of look at that, I'm taking n and I'm subtracting 2. That's the number of triangles, and then I multiply that by 180 to get the total number of degrees. And that is my polygon sum formula. So let's fill in the conjectures down here below. The quadrilateral sum conjecture just says the sum of the measures of the 4 interior angles in any quadrilateral is 360. You could also just use the formula 180 times n minus 2. 4 times 2 is 2. 2 times 180 is 360. Or you can just memorize this. One of the easiest ways I memorize this is just remember a rectangle is a quadrilateral. Every angle is 90 degrees. So 4 times 90 is 360 as well. The pentagon sum conjecture says the sum of the measures of the 5 interior angles in any pentagon is 540 degrees. And then our final conjecture, polygon sum, the sum of the measures of the n interior angles of an n-gon, just meaning any polygon with n sides. So n could just be a generic number, is 180 times the quantity n minus 2. Again, n minus 2 is the number of triangles you can form, and multiplying that by 180 because there's 180 degrees in each triangle. So we're going to do a little paragraph proof about this before we do some actual angle chase problems. So here we go. So we are given quadrilateral quad with diagonal DU as shown. Okay, so we're going to let Q equal measure angle Q, A equal measure angle A, D equal measure of angle QDU, E equal measure angle ADU, U equal measure of angle QUD, and V equal measure of angle AUD. Okay, so by the triangle sum conjecture, D plus Q plus U equals 180, and E plus A plus B equals 180. So now remember, we have this triangle here, which is the sum of D, Q, and U, and this triangle here, which is the sum of A, E, and B. Now, by angle addition, the measure of angle D, this angle, is actually D plus E. It's this part plus this part. Those are adjacent angles, and we sum them up, we get the measure of angle D. And the measure of angle U equals U plus V. By adding measure of angle Q plus measure of angle D plus measure of angle A plus measure of angle U, that equals, so what we're doing is we're adding up all the angles in our quadrilateral, right? Let's go back and look at that. Here's Q, D, A, U. Okay, so Q is Q, D is D plus E, which we just stated, A is A, and U is V plus U, or U plus V. Now, going back up here, we noted by the triangle sum, D plus Q plus U, D plus Q plus U is 180, and E plus A plus V, E plus A plus V equals 180. So that equals 180 plus 180 equals 360. Therefore, that's these three little dots, the sum of the interior angles in a quadrilateral is 360. So that's a little proof. And this was a generic quadrilateral, so it applies to all quadrilaterals. Let's do some angle chase exercises using some of our new conjectures. So let's look at problem 1. You can pause the video and then try these on your own or follow along with me. So for number 1, let's fill in some things we know. So vertical angles, so that's 78. Vertical angles, so that's 44. Then I notice that I have a triangle right here. So 78 and 30 is 108, and then I subtract that from 180. And so this is 72. I can use linear pair then to get C. So C is 180 minus 72. So C is 108. I could also use my exterior angle conjecture. Remember the exterior angle, this angle here is the sum of the remote interior angles. I could have used that. And then, again, you can get the, any of the angles in multiple different ways. I'm going to use quadrilateral sum to get angle D. So we know C is 108. I'm going to use a linear pair right here. So 180 minus 78 is 102. And then to get D, I'm going to use quadrilateral sum. So I'm going to take 360, and I'm going to subtract 44, 102, and 108. And D is 106. So that's how we find those two. For problem number 2, a couple things I noticed. First of all, I noticed a pair of parallel lines. So remember, I'm looking for alternate interior corresponding or alternate exterior, and I see a pair of alternate interior angles right here. So this angle is 38 degrees, so is K. Now, I'm noticing that I have a regular quadrilateral here because all the angle measures are marked congruent. And I'm noticing, too, that it is a 1, 2, 3, 4, 5, 6 hexagon. So for a hexagon, to find the total number of degrees, I'm going to use my 180 times n minus 2. There are 6 sides. 180 times 4 is 720. And then since all the angles are marked congruent and J is the measure of one angle, I take 720 and I divide by 6 because there are 6 total sides or 6 total angles. And so J is 120 degrees. For our last one, let's take a look at that. We have a lot going on in there. All right, so I filled in a couple already, and then I'm going to show you how I got some of these other ones. So number 1, again, let's just start at the beginning. Start with A. A is vertical to 116. And I can use linear pair to get this 64-degree angle. And then notice I have parallel lines. So alternate interior angles help me get B to be 64. Then I have a quadrilateral here that helps me get D. So I do 360 minus 116 minus 64 minus 98. And I also have a quadrilateral here to get C, because 90 plus 64 plus 116, and then subtract that from 180. So now I'm going to show you how to get some of the other angles. So notice a quadrilateral here, and E and P are congruent. So I'm going to take 360 minus 64 minus 98, and then I'm going to divide that answer by 2, because I have 2 angles there, so E and P are both 99. I also can do a quadrilateral sum here to get M. So 360 minus 60 minus 87 minus 77, excuse me, to get M, which is 136. And then this is another one that's kind of interesting. So notice there's this point, and this actually makes a circle, so that's 360 degrees. You can use that to get N. So do 360 minus 106 minus 136. So N is 118. I ran out of time, but here are some of the other answers.